Newton's Laws of Motion by Sylvie Stoller. Isaac Newton was an English physicist and mathematician who created a set of laws that explained why objects move the way they do, or why they don't move at all. Newton's first law of motion. Newton's first law says an object in motion tends to stay in motion. The object tends to move with the same speed and in the same direction. If no outside forces act upon the tennis ball will never stop moving. The friction is keeping the ball from slipping and moving. The curve on top represents the angular velocity. There is no forward velocity yet. This free body diagram shows once the ball has started rolling. Zero friction occurs only for horizontal motion at constant velocity. Newton's first law also says an object at rest tends to stay at rest. The tennis ball will not move unless acted upon by an external force. Newton's second law of motion. Newton's second law of motion states that if you exert the same amount of force on two objects with different masses, the acceleration of the two objects will be different. F equals ma. F is the net force acting on the object, and m is the mass of the object, and a is the acceleration of the object. It is difficult for me to kick the wall and move it because of the mass of the object. However, it is easy for me to kick the tennis ball because it has lower mass. This is the free body diagram for the moving tennis ball. Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. Forces come in pairs, but sometimes the reaction is difficult to see because of a difference in masses. Here we represent two equal but opposing forces. When the two equal but opposite forces meet, they create a net force of 0. I originally thought you had to make a video, until I later found out after I had begun filming that you could do a PowerPoint. Although I am more comfortable with PowerPoints, I saw this as a unique opportunity to try to make a video. I did struggle though with the editing of the video. When I filmed, I did not film with good lighting, and it is clearly seen in the video. I also struggled to add free body diagrams to the video and was unable to do so after trying for multiple hours. Newton's laws of motion have had a significant impact on how motion is understood by physicists and students alike. His contributions to the scientific world will forever be appreciated.